Hi to everyone. Today we are going to discuss about data leakage detection using Bigraph. In this work we have proposed a probability model. This work was projected in 7th International Conference on Communication and Network Security, Tokyo in 2017, and this paper was awarded as best paper. This work has been done with my PhD student Ishu Gupta, Department of Computer Application, NIT Kurukshetra. In this presentation, I will start through motivation, then introduction, guilty agent detection model, data distribution and probability computation, followed by experimental result with conclusion and differences. If you see this diagram, the attacks are increasing day by day. If you take it from 2005 to 2016, in 2016, see the pillar is reaching up to 2000. This data was taken by Identity Theft Resource Center, and before 2016, 2 years it was flat, which started from 2005. So the day by day data attacks are increasing, which provides a challenge for researcher how to protect the data. If we see that what type of data are attacked, so 432, if I take a graph of 1000, 432 data is attacked, and that data belongs to business. After that, the second one is 355. These are medical data. Banking data are more secure. Security layer is very high, therefore it has only 43%. 84% educational data, and 66 is basically taken by government and military. If I take an example, that survey was conducted by Phoneme Institute IBM report. According to this, electronic data breaches such as the recent ATM hack that comprises more than 30 lakhs debit cards have become more costly in recent years. Again, the graph is increasing here, starting from 2012 and 2016 it reached maximum, and the cost, which was rupees 2,106 in 2012, has increased to 3,704 rupees in 2016. So the money we are investing to protect the data is increasing day by day. What is data leakage? Data leakage is a kind of unauthorized transmission within from an organization to an unauthorized recipient, and the data can be either private or they can be sensitive information. Sensitive data are more important. People want to preserve the sensitive data, and which includes financial information, personal information like credit card and banking type of data. So if I take a scenario, how it works. So a particular very small example I am taking. First, there is a gentleman, Elish and Bob. Elish write up a proposal and shares the document with her team, and Bob copies the document and share it with his colleagues as a sample of good proposal. So the proposal was prepared by Alice, passed to Bob, and Bob shared that data with a particular colleague to use that data as a sample. And what happened? It was shared by X, but X passed this data to Charlie to write a proposal for XYZ using the sample document. That is an unexpected information leakage. And this model is designed to detect this kind of leakage because Charlie was not supposed to see the data, but intentionally or unintentionally, data was leaked by X. So where we can use cloud computing is the best example, because in the cloud environment we need to share the data, and cloud computing refers to the process of sharing resources over the internet, and that share can be either hardware, development platform, software, and it enables on-demand network access, and we can pay per use subscription basis. And the best example is electricity. We use electricity and pay accordingly. We don't worry about the whole infrastructure used to develop the electricity. Consumer has to pay how much electricity they have used. This is a kind of example where we have cloud computing have a lot of computer networks, servers, storage, and applications, services. So now people are moving through cloud environment, and data is also moving through cloud. And once the data is in cloud environment, means we are going to share among multiple sources, and therefore the chances to leak the data is more, and we need to prevent that leakage. This research is basically based on this. If I take a problem definition, like left hand side of this table, entities, there are three entities. The first one is distributor. It's a Facebook example. Second one is agents. Agents are the Facebook apps taken from UN to UN, and there is a leaker here. Leaker can be more than one. And the data set, T is the set of all Facebook profiles. R1 to Rn, set of people profiles who have added the application UI. So if I take a particular agent UI and Ri, so Ri is the set of people profile who have added a particular application UI, and S is the set of leaked profiles. In a particular case, if I am taking only 4 profiles, T has only 4 profiles here, and they are Catherine, Jeremy, Sarah, and Mark. And there are 4 agents taken from here, U1, U2, U3, U4. So these are 4, these are also 4, and each agent requests a sample of any 2 profiles. Any 2 profiles for T to make it survey. So if I take example here, U1, U2, U3, U4, these are the agents. They request profiles through Facebook. All are having different color. So U1 requested Facebook, U2 also requested, U3 and U4, and they are requesting any 2 profile. They are not saying that I need this particular profile. Out of 4, any 2 profile can be given to any agent. So here the request is delivered. R1 is for U1, R2 is for U2, R3 is for U3, and R4 is for U4. And S is the leaker here. S is the set of leaked profile, and in this profile S, there are 2 sets are leaked, R1 and R3. So R1 is, you can see, R1 was given to U1, and R3 is given to U3. This color also you can see, blank and blank. This is the black color, this is purple color. So the probability out of 4, the question is who has leaked this data? Who has leaked the profile of R1 and R3? So the chances for leaking is more who requested the particular data. Means if I calculate the probability of G1 to leak S is more than probability of G2 because the data is leaked R1 and R3, U2 was not having both. It means probability of G1 is more than U2. Similarly, probability of G1 is also more than probability of G4 because G4 was not having that profile. But when we compare probability of G1 and probability of G3, we don't know who is the victim because both are having the data. You can see U1 also have the data, which is R1, and U3 also have the data R3. Both are having the data. The distributor has given to both agents, therefore we are not sure that who leaked the data. In that case, we can calculate the probability. We can say that 50-50% chances are there. This is a kind of case. So what to do? If I take a kind of situation here, the theme of the work is how to distribute the data. We need an effective distribution strategy so that we can identify the leaker easily. It means the probability of detecting the leaker is more. So in this case, if you take U1 has taken both U2, U3 and U4. All 4 are getting the same type of profile. All 4 are getting same type of profile. It means if someone leaked, then the probability is 25% because 4 agents are there and all 4 agents are having the same profile. It means anyone can leak, therefore the chances are 25%, which is a kind of poor distribution strategy. The good distribution strategy is U1 is having this, U2 is this, U3, U4. So all these 4, if you see, only one profile is given to a particular agent and this particular agent leaked, immediately identified that okay, U1 is the guilty agent because this profile was given to U1 only. Similarly for U2, if it leaked this, it means responsibility goes to U2. Same is true for U3 and U4. But the condition is we have to give 2 sample profile. So if the second one is given, so you can see U1 has taken these 2, U3 is U2 is this is 2, again this is U3 is these 2, and this U4 is these 2. It means the probability is 50-50 because the set is given to U3 and U4 both. So if these 2 profiles are leaked, means responsibility goes to U3 and U4. If these 2 profiles are leaked, it means responsibility goes to U1 and U2. So what should be the optimal case? The optimal case is if we can avoid full overlapping, then we can say that yes, this is the best distribution. So this is a kind of case which is full overlapping avoiding, and again you can see this all are here. So no one has same type of set. If these 2 are leaked, it means it is leaked by U1. If these 2 are leaked, it means leaked by U2 and U3 set this 2 set leaked, then U3 and U4 is this first and last. So the target is how to avoid full overlap, which is the optimal case, and it's not always possible. So we should have some kind of distribution strategy which minimize the overlap. If it cannot avoid full overlap, at least it can minimize the overlapping. And in this research work, we have used Bigraph to avoid overlap. So there are solutions for data protection, and the data protection solutions can be divided into two parts. The first one is data leakage prevention, and the second one is data leakage detection. So this work is devoted to data leakage detection. For prevention, many techniques are there. We can use cryptography, we can use steganography, and a lot of techniques are there. But after that, still if the data is leaked, data is misused, then we have to identify the guilty user who is responsible to leak the data, and this work is fall into the category of data leakage detection system. So what is the formal definition of data leakage detection? Data leakage detection is typically defined as any solution or process that identifies the unauthorized disclosure of the confidential data, and there are especially design systems that have the ability to monitor and protect confidential data, detect misuse of confidential data, and identify the malicious entity responsible for the data leakage. So in our model, we consider some kind of preliminaries. We consider that there is a distributor, and that distributor has n number of data from D1 to Dn, and that has to distribute among agents, n number of agents which start from A1 to Am. And what is the goal? The goal is distributor doesn't want the data to be leaked to some malicious entity, and particular agent Aj receives a subset of data objects Xj, which is a subset of D. Means if someone requests the data, any agent requests the data, data is passed among D1 to D1, D1 to Dn. It means it's a subset by requesting the condition of the distributor. Maybe the distributor has some kind of conditions on which condition he can distribute the data among users. The entity is said to be guilty agent that leaks the data from its allocated data Xj to some unauthorized recipient, which may cause the misuse of data. So this particular entity, if it leaks the data at some unauthorized place, so this particular entity considered as a guilty agent, and we are representing that guilty agent using GA. We are using the bigraph. The basic definition of bigraph is the graph GUV is said to be bigraph if and only if whose vertices can be divided into two disjoint sets U and V, such that intersection of U and V is a null vector. Means nothing is common among set of two vertices. So this is a kind of case. This works like this, U1 and V. So see that there is no connection. There is no connection between U. There is no connection between V. So the connection is only possible from U to V. So that is a bigraph. There cannot exist any edge E between two vertices of the same set. The model is like this. We have a distributor here. This distributor maintains a database. This database is using bigraph, where data is D1 to Dn, is a U here in the bigraph. This side U, and agents are V here, A1 to Am, and the data are distributed. So any data can be given to any agent. Means one data can be given to more than one agent, or one agent can have more than one data. It means it's not one-to-one mapping. It depends on application. Maybe for some application we need to distribute a particular data among multiple agents. especially in the medical side or like banking sector also. Sometimes we have to give a particular data to more than 2-3 entities. In that sense, if any agent leak the data, you can see here the data is leaked, then this leaked data, this distributor find the data at some unauthorized place. Means data was given to a particular agent, but that data is passed to someone which was not supposed to get that data. That distributor found, and then after that it applied the guilty agent detection. Guilty agent detection model comes here, sub-model, where the leaked document compared with the allocated document. So for example, A1 and A2 is leaked, then it compared that this particular A1 and A2 was given to whom, and we have calculated the probability estimations and then find the guilty agent. This is our proposed model. How it works? Distributor shares all the data objects D1, Di, where I belongs to between 1 to n among various agents, Aj, where J varies between 1 to m according to their demand. Later on, if any agents leak the data at some unauthorized place and the distributor find it, then leakage detection technique is applied to find the guilty agent responsible for the data leakage. Probability is calculated to assess the likelihood of any entity for being guilty, for comparing the data allocated to various agents, and then the guilty agent is identified. So, how we are distributing and how we are calculating the probability computation. That's a big question. So for data distribution, this allocation and distribution of data among various agents use a directed bigraph. Means if any data object Di is allocated to an agent Aj, then an age E exists between the node Di and Aj, where Di belongs to D, Aj belongs to A, and E belongs to E. So this directed bigraph we can represent into n cross a matrix, where n is the number of data, m is the number of agent. So if Bij, if there is a connection, then output is 1. If there is no connection, it is 0, which indicates that if the data is allocated, then we consider 1 in the matrix. If the data is not allocated to a particular agent, then we consider 0. CDI is another parameter, is equal to J to M. We are taking summation of Bij, and Raj is equal to I to N Bij. So I to M is the number of agent, this is I to N is number of data, and the entries Bij belongs to B is 1 if there exists an age between data Di and agent Aj. CDI is the number of agents to whom data object Di is allocated, and Raj number of requests fulfilled by the agent Aj, which indicates that one particular data Di is allocated to more than one agent. This Raji is one data, the agent can have more than one data. So number of requests means number of data whatever he asked is fulfilled by the particular agent. Means one data can be distributed to more than one agent, and one agent can have more than one data, that is represented using bigraph. And the data is encrypted first. In the prevention I told that we are using the encryption technology so that the data is not naked. So encrypted document Di is passed to the Aj agent, and then the key is passed to AJ and he can use the key and utilize the data effectively. But after opening the key, after decrypting the data, he can leak to someone. Decrypted data can be leaked to the unauthorized party. And the question is how to identify that leaker. If we are taking mathematical formulation, if any agent AJ leaked the data at some unauthorized place and the distributor discover it, then detection technique is applied to find the guilty agent GA by calculating the probability on the basis of the data allocated to the various agent. So the probability is calculated first G AJ, G represent guilty, A represent guilty agent, and the event that AJ is guilty agent G. The probability PB for being a guilty of any agent. When leaked data set we know, conditional probability, when leaked data set we know, the probability of being guilty of any agent is equal to 1 minus DI belongs to leaked data set intersection of Xj 1 minus alpha divided by CDI. If AJ leaks all the data objects, whatever the data is given, all data is leaked. In that case, it's allocated Xj, then L become Xj. So for example, if 5 data is given, D1, D2, D3, D4, D5, and if all 5 are leaked, means L is equal to 5, means L is equal to D1 to D5. But it's also possible that some of the data is not leaked out of 5. In that case, we take the value of L here. Therefore, we are using conditional probability, that it is calculated based on the probability how many data is leaked. We define a difference function, sigma star jk, GA, to maximize the possibility of identifying GA who leaked all its data given as this, using this equation. So you can see here, it's a difference. It's a difference between probability of being a guilty agent AJ, Xj, minus another one, K, AK, if we know Xj, where J and K both varies between 1 to N. So that is a difference function here. Another parameter we are taking, average success rate. Average success rate for guilty agent sigma star bar and detection rate when 2 agents have some guilty probability which is minimum sigma star. These are the equations both. So we are taking the summation of these things. This is the algorithm which we have developed, and where this is the set of bigraph here. So the first data is distributed using bigraph. After that we apply the loop here, calculated the value of CDI, calculated the value of RAJ, XJ, and then finally we are calculating the probability. Here you can see PB, then we are calculating the average success rate, and these are two another parameters is calculated. So what type of result we receive? To get the result, we have implemented our code in C and C++. Consider the simulated data leakage problem to conduct the experiment. We have evaluated the performance of our framework by computing the probability against the parameter called as weight factor WF, defined as the ratio of the sum of all the allocated data objects to the number of data objects, that is the weight factor. WF is equal to J to M. J to M means M is the number of agent here, or AJ, RAJ